Bismillahirrahmanirrahim. Assalamu alaikum. I am Sajida Imran, your chemistry teacher from Rangers Public School for Boys, Lahore. Hopefully, all of you will be in good health. This is the second day of the 7th week of our online classes. As you know, we are discussing the third chapter, that is periodic table and periodicity of properties. In this chapter, up till now, we have discussed the periodic table, the method to find out the period and group of an element through electronic configuration, valence shell electronic configuration, and position of an element. Today we are going to discuss the periodicity of properties and shielding effect. Our objectives are, at the end of this lesson, you will be able to explain the variation of chemical and physical properties in periods and groups, and you will be able to describe the shielding effect and its trends in period and group. Now we are going to discuss our first topic, that is periodicity of properties. As we have seen that the electronic configuration of elements show a periodic variation with the increasing atomic number. Therefore, the elements also show periodic variation in their physical and chemical properties. There are two types of properties, physical and chemical properties. Chemical properties depend on the valence shell electronic configuration, and we have discussed before that all the elements of a particular group have similar valence shell electronic configuration, so they possess similar chemical properties. Physical properties depend on the size of atoms. Since size of atoms changes gradually from top to bottom in a group, therefore elements show gradation in physical properties in the same group. In a period of periodic table, the number of electrons present in the valence shell increases gradually from left to right. Their chemical and physical properties also show variation in the same manner. So, we have seen that the variation in both chemical and physical properties due to variation in electronic configuration in periods. Now, our second topic is shielding effect. This is the structure of lithium. Students, this is the Bohr atomic model of lithium. Lithium, the symbol of lithium is Li. Its atomic number is 3. So, it has two shells. The first one is K shell. It has 2 electrons, and the second shell is L with 1 electron. Now, this is the Bohr's atomic model of beryllium. Its atomic number is 4. Its first shell is K with 2 electrons, and the second shell is L shell with 2 electrons. Now, this is the Bohr atomic structure of magnesium. Its atomic number is 12. It has 3 shells, K, L and M. First shell is K, it has 2 electrons, second L with 8 electrons, and the third is M shell, it has 2 electrons. Now you can see that lithium has 1 inner shell, beryllium has 1 inner shell, whereas magnesium has 2 inner shells. So the size of atom increases from lithium to magnesium. Shielding effect. Now our next topic is shielding effect. It is also known as screening effect. This is a structure of lithium. It is known as Bohr's atomic model of lithium. The symbol of lithium is Li. Its atomic number is 3, and it has 2 shells. The first one is K shell, it has 2 electrons, and the second is L shell with 1 electron. This is the atomic structure of beryllium. Its atomic number is 4. Its first shell is K shell, it has 2 electrons, and the second one is L shell with 2 electrons. And now this is the structure of magnesium. Its symbol is Mg, its atomic number is 12. You can see that it has 3 shells, K, L and M. First one is K shell, it has 2 electrons. Second is L shell with 8 electrons, and the third is M shell which has 2 electrons. Now you can see that lithium has 1 inner shell with 2 electrons. Similarly, beryllium has 1 inner shell with 2 electrons, whereas magnesium has 2 inner shells with 10 electrons. As we know that there are attractive forces between the nucleus and the outermost shells, or you can say outermost electrons or valence electrons. So these attractive forces are reducing from lithium to magnesium because the number of inner shells or the number of electrons are increasing. The force of attraction in lithium between nucleus and the outermost electron is stronger as compared to the force of attraction between nucleus and the outermost electron in magnesium. This reduction in force of attraction between nucleus and the outermost electron is called the shielding or screening effect. I will repeat it again. The reduction in force of attraction. फोर्स ऑफ अट्रैक्शन में कमी को हम शील्डिंग इफेक्ट कहते हैं. दिस फोर्स ऑफ अट्रैक्शन इज स्ट्रॉन्गर इन लिथियम, सो इट हैज़ स्मॉल शील्डिंग इफेक्ट as compared to magnesium. Magnesium has more shielding effect because it has more shells, or you can say more inner electrons. So because of inner shells or inner electrons, the force of attraction between nucleus and the valence electron is less in magnesium as compared to lithium. This is called the shielding effect. Now we will see its proper definition that is given in your book. The reduction in force of attraction between nucleus and the valence electrons by the electrons present in the inner subshells is called shielding effect. Now we will discuss its trends. When we are talking about the trends, then we will discuss these trends from periods point of view and from groups point of view. First of all, we will discuss the shielding effects trends in periods. As we know that the horizontal lines in the periodic table are known as periods. So look at this picture. In this picture we can see the third period that starts from sodium and it ends on argon. Ar, argon, that is a noble gas, and this third period starts from sodium, atomic number 11. As we have discussed earlier that in the period the number of shell remains same. So sodium has 3 shells, whereas argon also have 3 shells. But the number of electrons in argon are greater than sodium. In argon, the number of electrons in the outermost shell are 8, whereas in sodium, the number of electrons in the outermost shell is 1. But the inner shells or the inner electrons remain same, and these electrons or shells are same as we start from sodium and ends on argon. So if the inner shells or the inner electrons remain same, it means that they have same shielding effect. So shielding effect does not change as we move from left to right in periods in periodic table. So we can say that the shielding effect in periods remains constant. However, the atomic number increases as we move from left to right. For example, sodium and argon, as we have discussed, contains 8 and the third is 1. And in argon, the first shell contains 2 electrons, second 8 and the third is 8. So atomic number of argon is 18. First shell with 2 electrons, second shell with 8 electrons, and the third shell again with 8 electrons. So argon, the atomic number of argon is 18, whereas the atomic number of sodium is 11. Though the atomic number increases from left to right, but because of constant inner shells or inner electrons, the shielding effect remains constant. Now we will discuss the shielding effect in groups. Groups means the vertical columns or lines in the periodic table. As you can see in this picture, the first group that starts from hydrogen and it ends on Fr. We have drawn 4 structures of first group that are hydrogen, lithium, sodium and potassium. You can see that in hydrogen, atomic number 1, it has only 1 electron that is present in the first shell, whereas in potassium the atomic number is 19. The first shell contains 2 electrons, second with 8 electrons, third again 8 electrons and the last one has 1 electrons. As we move from top to bottom in a group, the number of electronic shells or the inner electrons are increasing. The number of electronic shells or inner electrons are increasing. So when the number of inner electrons or the inner shells are increasing, there is reduction in force of attraction between nucleus and the outer electrons happens. When this attraction between nucleus and the outer electrons occurs, it means that the shielding effect increases from top to bottom. So hydrogen has less shielding effect as compared to potassium. Now we will discuss the example 3.5, in which we have to identify an atom with greater shielding effect. Its first part is beryllium or magnesium. Beryllium, atomic number 4, 2 electrons in the first shell and then 2 electrons in the second shell. Whereas magnesium, atomic number 12, it has 3 shells. The first shell contains 2, second 8 and third 2 electrons. So you can see in the periodic table that beryllium and magnesium are present in second A group of the periodic table. As the number of shells increases down the group, so magnesium has more shells or more inner electrons as compared to beryllium. So the shielding effect of magnesium is greater than beryllium. Same will happen in the case of carbon and silicon. Carbon and silicon are present in 4A group of the periodic table. Carbon is present on the upper side and silicon is present on the lower side of the periodic table. The atomic number of carbon is 6, whereas the atomic number of silicon is 14. So as we have discussed that as we move from top to bottom in a group, the number of shells increases, therefore the shielding effect also increases. So the shielding effect of silicon is greater than carbon. Now your home assessment is define shielding effect, discuss its strengths in period and group with examples, and solve self-assessment exercise 3.5, which has been given on page number 52, and inbox your assignment to your relevant teacher. Thank you. Have a nice day.